Hey guys, this video is about reflections, which some of you may have learned about in 8th grade. Some of you may have not learned about reflections. So I'm going to go through the video. Feel free at any time to pause, fast forward, rewind, whatever you need, depending on your background in this topic. Okay, so the first thing you want to know about reflections is the definition right here. So the definition of a reflection is just a mirror image of any figure over a line of reflection. So we are going to primarily be doing reflections on the coordinate plane down here. But just to give you a little example, you always would start out with something called a pre-image. That's the object or the figure that you're trying to reflect. And then the line of reflection will tell you where you're going to reflect that object. And so one part on the pre-image would correspond with the same type of part on the image. And we would mark the image with prime symbols. So here you can see A reflects to A prime, B reflects to B prime, C reflects to C prime. And at the end of your reflection, your image should look the same as your pre-image because we are not affecting the size at all. Okay? There are 4 properties preserved whenever you do a reflection. And the easiest way to remember those properties is by just remembering A, B, C, D. So the A stands for angle measure, which you can tell maybe from our diagram up here. These angles are not changing. They just are facing a different way. The B stands for betweenness, which is kind of a silly word, but just means that if a point is in between 2 endpoints, when you reflect it, it's still going to be between those endpoints. Collinearity, similar but slightly different because you can have multiple points that are collinear. Whenever you reflect an image, it will still be collinear. And then lastly, distance, which we can also tell by our little example, because whenever you reflect a figure, the size does not change. So therefore, the distance between the points must remain the same. So these are the 4 properties that are preserved from reflections. And as we go through each transformation, I'll kind of be going back to this because certain transformations have different properties that are preserved or additional properties that are preserved. So if you haven't already, you want to go ahead and get a little piece of graph paper. If you took some from class, you can just cut it out and tape it right into your notebook, or you can draw a sketch of the X and Y axis. You don't really need the grid unless you think it's really super helpful. The first set of examples are all going to be reflecting over the Y axis, which you can see a little bit. I've outlined it here in red. That's our Y axis. And you've done this before if you took 8th grade math in West Hartford, but the notation you have not seen. So instead of writing out in words, reflect over the x-axis, in this class you'll be seeing the questions worded like this. So a lowercase r, that stands for reflect. And I would write that down even if you think it's self-explanatory, because when we get to rotate, it also starts with R, so you want to know the difference. The subscript stands for the line of reflection. Like, what are you reflecting this over? And in this case, it's the y-axis. And then anything in the parentheses is our pre-image, the result, or equals our final image. Okay, so I'm going to go through each example in a different color so we can distinguish them. So the first one says reflect over the y-axis the point 4, 5. So I'm going to graph 4, 5, going to label that A, and I'm reflecting over my y-axis, which means it should hop over here somewhere. right? And every time I do a reflection, distance remains the same. So you can use that, like counting of the grid. 1, 2, 3, 4. It's going to reflect 1, 2, 3, 4 on the other side of my line of reflection. And whenever you reflect a point, you would typically use the same letter, A, but to show that it is a image, you would put the little prime symbol like I did up here as well. Now we would want to write the coordinates for A prime, which would be -4, 5. This is A prime. That one was A. Okay. Reflect over the y-axis, -6, 2. So this time my point's going to be -6, up 2. I'll put it in blue there, just so we can see the difference. So this is point, I'm going to call it B. Just like I reflected A to A prime, I'm going to use the same method. So B is 6 units to the left of the y-axis, so I'm going to count 6 units to the right of my y-axis. Label that B prime. And the coordinates for B prime are 6, +6, 2. Go ahead and try parts C and D. Then resume the video and see if you got them right. Hopefully some of you guys have started to notice some type of a pattern. So whenever we reflect over the y-axis, we're either reflecting over to the left or to the right because our line of reflection is vertical. Now if we look carefully at our coordinates, you'll notice that the y coordinates for all of these reflections remain the same. So that's our first conclusion. Y coordinate stays the same. And our x coordinate is almost the same, +4 to -4, -6 to +6. So you wouldn't want to say that the x coordinate becomes negative because, for example, in parts B and C, it actually becomes positive. So we're going to summarize this by saying x coordinate, you could say changes sign or becomes opposite side, opposite sign. So we'll go ahead and use the same coordinates to reflect over the x-axis, and just like I explained the notation on the previous one, so we will not really be seeing a ton of examples that are written out in words, so you want to make sure when you see this notation you understand I'm asking you to reflect over the x-axis. I'll give you my pre-image that I want you to reflect, you're going to give me the image. So here's 4 examples. We're going to reflect this time over the x-axis. Starting with point A, I'm going to use the same one, so 4, 5. Now instead of reflecting left to right, I'm reflecting up or down. So A is 5 units above the x-axis, so I'm going to reflect it 5 units below and label that A prime. So my new coordinates would be 4, -5. A prime. We'll do the same thing for B. -6, 2, so here's point B. And if I wanted to reflect that over my x-axis, that would be just 2 units below right here. So my coordinates for B prime are going to be -6, -2. Go ahead, pause the video, try to complete parts C and D, and then resume when you are ready to check. Okay, so what conclusions can we draw about reflecting over the x-axis? Well, we notice our x coordinates stay the same this time. and our y coordinates change sign. Positive becomes negative, negatives become positive. So they're opposites. Example 3 is reflecting over the line y equals x. In case you don't remember, that's this red line that I've drawn in. So on your graph, you want to draw that in because it's already not on there. Whereas the x and the y-axis were kind of already there for you. Same notation, reflect over the line y equals x, your pre-image and then your image. So we'll go ahead and fill in the same coordinates we've been working with. And now we're going to reflect them. So 4, 5, that's our point A. To find A prime, we need to know how far away A is from that line y equals x. So some people use a strategy to like kind of box in that point, like similar to the same strategy as rise over run, and then kind of box in on the other side. A is going to be, A prime is going to be right there, right at 5, 4. So we'll try with another point, -6, 2. This one's a little bit further away. You name this one B. Get my color. B is all the way out here. So try that strategy where you kind of can box it in. And then fill in your box on the other side. B prime is going to be right here. Sorry, it's kind of a light box, can't really see it. So what I'm doing with this box method is I'm drawing a vertical and a horizontal line connecting my pre-image to the line of reflection. It's like the same idea as before, only I only needed to draw one of them to count the units. Now I need to do 2. And that's where B prime is going to be located. At 2, -6. Once again, go ahead and pause, do the reflections for C and D, and then see if you can start to come up with some type of a conclusion. So what I start to notice right away is that unlike the x-axis and the y-axis, the signs of my coordinates are not changing. These were both positive, they remained both positive. The -6 was negative, and it is still negative. So the signs are not changing, but there is something that does change, and hopefully we'll be able to see the x and y coordinates just flip-flop. So x coordinate and y coordinate switch. So my rule for reflecting over the x-axis, so whenever I have a point x, y, that's going to be, my result is going to be y, x. Examples 4 and 5 are new to everybody, even if you've learned about reflection, so you definitely want to write this down. Reflecting over any horizontal or vertical line. So an example of a horizontal line would be the equation y equals 5. So just to rack your brain in case you don't remember, the line y equals 5 is going to look like this. Oops. That's my line of reflection. Because no matter where I am on that line, the value of y is always 5. So let's choose 3, 4. So we'll go A to A prime. So I have my line of reflection, I outlined it in green. Here's my point A. And just like we would reflect over the x-axis, I'm going to count my units. So it's 1 below, it's going to reflect 1 above. So 3, 6. The next example says reflect over the line y equals -5, and we'll use the point -1, -1. So first step is we need to find our line of reflection. So find where y is -5. There's my line of reflection. Then I want to graph my point. So we'll label this one B. -1, -1. There's point B. And it is 1, 2, 3, 4 units above. So 1, 2, 3, 4 units below is going to be my image, which is -1, -9. Here's one more example for you to try. You can go ahead and pause. See if you can figure out any type of strategy that might help you figure out these reflections, as they don't really have a rule or a conclusion for all horizontal lines, but you might be able to figure out some little trick that works for you. Last example is reflecting over any vertical line, and vertical lines are denoted by equations that say x equals a number or a constant. So here we go. We'll use 3, 4 again. So first step is we need to find our line of reflection. X equals 5 is right about here. So my vertical line is going to look like this. No matter where I am on this line, the value of x is always 5. So my coordinates, we'll call that A. 3, 4. So here's A. Similar to reflecting over the y-axis, only this time it is x equals 5. So it's 2 units to the left, I'm reflecting 2 units to the right. A prime. So B 7, 4. Go ahead and try B and C, and then resume the video when you're ready to check. And I forgot to give you points actually, so here you go, try it now. Hopefully you're able to see that these are a little trickier to find our rule. You might be able to notice that the y coordinates stay the same when you reflect over a vertical line, and the x coordinates stay the same when you reflect over a horizontal line, but there really is no rule to figure out the other coordinates. It all depends on where the line of reflection is being placed. If you still have questions about reflections, please come and see me, especially if you did not learn this in 8th grade, so we can get something set up for you guys. Thanks for watching.